we'd like to invite Dr. Zbigniew Klimont, Research Group Leader and Principal Research Scholar, Pollution Management Research Group, Energy, Climate, and Environmental Program. He works on the development and assessment of regional and global emissions of various air pollutants and midterm scenarios. He has been leading the development of GAINS modules to estimate emissions and control costs of reducing emissions of ammonia, volatile organic compounds, and particulate matter, including black carbon. The GAINS framework continues to support the development of air pollution policy in Europe. He has been involved in European and Asian work on emission control strategies for more than 2 decades and has co-authored Asian, European, and global inventories and policy studies on air pollutants and their future evolution, with a specific focus on black carbon and other aerosols. He has authored and co-authored over 130 peer-reviewed papers, was a contributing author or lead author of the IPCC Working Group 1 for 5th Assessment Report AR5 and Working Group 1 and 3 of the 6th Assessment Report AR6. He has also the lead author on a number of global and regional Asia and Latin America climate and air pollution assessment led by United Nations Environment Program, as well as the Arctic Monitoring and Assessment Program, AMA. Assessments. So, Dr. Klimont provides viewers, please.
Good afternoon, and thank you very much for giving me the opportunity to speak at this meeting. And thanks a lot, Dr. Yamashita, for very kind words of introduction. So let me say a few words. I'm just trying desperately to switch off one of the windows here. Let me say a few words about a very broad topic actually, about integrated assessment modeling and application of that to the Air Convention over the years, over 40 years, although the EAMs, the integrated assessment models, have not been used throughout all the time. I have been hesitating during my thinking about the presentation, how far back in time I should go, and I decided to jump back more than 20 years to the discussion that was preceding the signature of the Gothenburg Protocol that you have heard already earlier from Anna, who mentioned actually the several of the process and the protocols that were signed under the convention. This is a very important one because it put together a lot of information about different pollutants. It was the first one that asked for reductions of multiple species. The slide that you see here is illustrating the discussion that was taking place at the time, and to my mind is a good illustration also of giving the rationale for utilization of models that could put a lot of different information together. Actually, many of the things that we have heard in the previous presentations stemming from emissions of various sources that would affect then health and ecosystems, information about economic costs associated with mitigation. What you see here is an example of an optimal, cost-optimal strategy. That's the line that is an example here for ozone, but it's actually independent of pollutant. This would look slightly different, of course, for different species and effects, but here just to illustrate how population exposure would change over time from a reference point, some future scenario, in this case, looking into 2010 at that time. And here are different options that are compared. I would like to compare one point on this curve that presents a least cost solution according to the model. This scenario, this point G52, compared to the other 2 points. In all of these cases, emission reduction would be exactly the same. So we would achieve the same total reduction of various pollutants contributing to the reduction of ozone exposure. But as you see here, the impact, which is presented on the x-axis, and the costs would be very, very different. And these are the typical questions that are this question of fairness, of distribution of effort, of burden between different parties is always coming up in the discussion. So here, for example, this point is illustrating uniform reduction, like many of the original and early agreements were asking for example, the first sulfur protocol was asking for 30% reduction from all countries. So this could be this kind of example. The other one would be a different distribution of reduction burden. Per capita emissions would decline equally across the whole region, or utilizing integrated assessment models and suggesting actually unequal distribution, but optimized from the perspective of costs, and eventually achieving much larger effect at a lower cost. Of course, the final solution is somewhere in between, because there is a number of other policy-related factors that will be taken into account during the discussion. But the point here is that the models can support this discussion by providing alternative and a number of alternative solutions. The cost effectiveness approach that is used and developed in the models and implemented in the models, like this integrated assessment models like GAINS that have been used in the discussion, they allow to separate the responsibilities and the tasks of policy and those who deal with technical issues. Decision makers have to still take the decisions about the ambition level, for example, environmental targets and how they want to achieve them over time, the level of acceptable risk and associated costs, willingness to pay for this mitigation. While on the modeling side, we will be able to quantify a number of policy scenarios and assess a number of these policy scenarios, providing information about the distribution of burden and balanced control over different countries, sectors, and pollutants. We would consider different factors that are fact across Europe, but also Asia, many other places, about the distribution of emissions and also variability in sensitivity of ecosystems across the region. That will allow us to build a robust set of strategies that can be then discussed between the decision makers. To give just a flavor of that, an example, this is for European Union for 2005, the chart that is showing the mean exposure, that's the blue bars, to PM2.5. And you see that there's about a factor of 2 difference between different countries in Europe, or even 3, consider that somewhere between 5 and 20. This is population weighted PM2.5 in 2005. So it's not showing, of course, some of the peak areas. And then the brown yellow bar is showing here per capita GDP. So you see that there are big differences between, and this is across the European Union. The variability would be greater if I would present here total UNEC and convention region. Similarly, another challenge is that there are large differences in the contributions of different sources to ambient PM2.5, just to focus on one of the pollutants. There's an example here of Netherlands and example of Poland, which this is the same scale on the y-axis here showing the population weighted PM2.5. And the colors indicate different sectors that contribute to the pollution, while on the x-axis, you see in a way distance from the source and the contribution also of local, national, and transboundary international contribution, which is marked here as the international. So you see here the structure of sources is also very different across countries. And so this requires an integrated approach that would allow to distribute efforts and take that into account, that in countries like Poland, households and solid fuel use for heating is an important element of the strategy, which is not appearing important in the Netherlands, while the green area here is linking strongly to agriculture sector, which has also different importance. The indicated level of 10 micrograms, this is the previous WHO guideline. The current one is 5 micrograms. So now the 10 is the interim target 4, as the Rota has been just showing in previous presentation. This has been discussed, a lot of that has been discussed and summarized in the scientific assessment report in 2016. And this report highlighted also an important role that in this discussion that climate change and climate mitigation strategies have, as well as other areas that would need to be addressed simultaneously. Air pollution should not be seen in isolation, and the policies can only benefit. This was highlighted already by previous speakers, as well as the issues related to the multi-scale approach that is also very important and has to be pursued further, so that local regional, as well as larger scale hemispheric work and strategies have to be seen together, because the opportunities that can be achieved, can be cost effectiveness is improving when considering these different scales explicitly in modeling. And integrated assessment models provide that possibility. Now, this is a very busy slide listing a long set of different legislation in Europe that links to air quality. I want to highlight here the fact that in 1994 was the first time when integrated assessment modeling was used within the Air Convention for the Second Sulfur Protocol, and considering at that time the cost effectiveness of distributing burden sharing or distributing reductions across different countries, considering cost effectiveness analysis. And what followed is a series of different efforts. Here you see a list for both development of the Gothenburg Protocol, review of the Gothenburg Protocol and its revision, and then ongoing now review of the Gothenburg Protocol, as well as many of the European policies that are closely linked. There's a close relationships between the two, including also European Green Deal and Fit for 55 legislation that is strongly related also to air quality and brings co-benefits to air quality, and mentioned already impact assessment of the revision of the air quality directive that has been just concluded and announced a few days ago. So the EAMs within the convention, as well as the European work, they allow to assess future situation based on current policy, as well as different alternative futures with different policy interventions. And they focus on identification of cost-effective packages that would deliver across many of the domains. And they reveal multiple benefits. An example of the tool, and the tool that has been used in these assessments, is the GAINS model that allows systematic quantification across sources, assessing the strength, evolution over time, and effective costs of mitigation, as well as comparison with different policies. So what you see on this diagram, I'm not going to go into details in here, but what you see is the blue lines here, or the blue arrows, indicate a simulation type of mode from starting with the social development and projections of activity data, energy use and agriculture. In the model, we have an assessment of emissions and costs of control, and then simulate together with our partners in Oslo the atmospheric dispersion that allows us to calculate then the deposition and concentration of different substances, compare it to policy targets, for example, databases on critical loads or WHO targets on health. And this can be run in a simulation mode to construct different policies and assess the implications for different impacts, but also can be run in an optimization mode where we will be designing least cost strategies to achieve particular targets. I want to give an example that goes back to the revision of the Gothenburg Protocol in 2012, where particulate matter was also added. And at the time, the CIAM, the Center for Integrated Assessment Modeling, work and the task force on integrated assessment modeling, ideas that were proposed by those were supported by the working group on strategies, and to develop and set targets for the future discussion. The principles that were defined were that environmental targets have to be achieved in all of the countries and should result in internationally balanced cost and benefits. And this resulted in 4 options that were analyzed. We have no time to go into them, and they are fairly complex. There was a very complex analysis that was preceding the analysis, but it went to the 4 options actually explored this different way of defining future targets for health and environmental reduction of health and environmental impacts, going from absolute targets defined, for example, as concentration or deposition values, to a distribution of gap closure across different countries. Now, the gap closure, I put here a little chart. The gap closure means that within the scope of mitigation, which is, for example, indicated here by the orange part of the bar for different effects here, we are seeking a solution across different countries. And of course, these bars will look different across different countries, between the top of the bar, which should be achieved in the baseline case, to the best available technology application case. And we are seeking here for different closure of that gap between the baseline and the maximum feasible to achieve the determined targets. Now, to give an example of that, the option 4 that is looking into least cost solution across the region, here an example for particulate matter impact on health from particulate matter is shown, looking into 2 cases. So you see a stepwise approach of reducing the impacts for a Europe-wide target, that's the lower bound in here, or achieving the same targets of reducing by 25, 50, 75% the health effects for each of the country, and assuring that for each of the country within the whole domain, these targets are achieved. And the costs in that case are obviously larger than when a widely distributed targets would be asked for. Now, the important thing is, of course, the distribution across many countries when we come to the discussion. And this is showing here all of the UNECE domain. And what you see here, the black dots indicate level in 2000. An improvement, this is life, loss in life, in statistical life expectancy in months. And this strategy of reducing this by 75% country-specific targets are achieved at either country-specific solution or Europe-wide. You see that there's no big differences in many cases, although in some you will see, even on this scale, some differences like here, or in this cases, Latvia, for example. So these are showing a different distribution in terms of months, but there's sometimes small differences that are hardly visible here. The few percent difference means a lot in terms of costs. And this is an important aspect of that analysis that this kind of models can provide. You see that the blue bars here, where the country solutions were asked, and for each country the target is met, are much more costly than when the improvement is asked across all Europe. While in terms of impacts, the differences were not that large. So this is illustrating how such approaches can be used. The conclusion from the analysis of the 4 options have been, and I did not have time to present that, of course, but that there are big differences depending, of course, on the definition of this target. And that was subject of discussion at the time, where the integrated assessment modeling supported then an assessment for each of them, to what extent this is useful or feasible from the perspective of the policymakers to achieve actually an agreement. And some of this, when asking for absolute targets, shows that it's very difficult to produce equitable distributions, while the reductions that would ask for relative improvements across many countries, and this is case 3 and 4, that they would allow to find equitable solutions and a fair distribution across the countries. And in principle, these 2 were used eventually to shape the proposal for the Gothenburg Protocol revision. Now, just a few slides showing where we are now and what the future brings the current review of the Gothenburg Protocol, and I will just share you very quickly the emission trajectories, in a way a success story for many of the cases. For SO2, you see the blue line here is indicating expected evolution of emissions within the region, divided here into North America, European Union and EFTA, UK. This is Central Asia and Turkey, and West Balkan. In all of them, sulfur dioxide is going to decline very strongly. In some of the regions, the other two lines show actually mitigation scenarios, two different variants of mitigation scenarios. The potential is not very large apart from Central Asia. For NOx, the picture is somehow similar in terms of a blue line and a rather strong mitigation in the baseline in most regions, but there is a little bit more potential that is still available to mitigate NOx further in the technical scenarios, as well as this low scenario is actually indicating a climate scenario similar to below 2 degree global target. Switching to ammonia, the picture is very different because the blue line indicating the baseline is rather flat and very little is happening in terms of current policies. And therefore, the further potential is still untapped and available, both in terms of technical measures, as well as further mitigation that is linked to transformational changes, including, for example, diary changes that would bring emissions of ammonia down and have co-benefits on methane. Finally, primary PM2.5 changes. This is something that, again, in some of the regions, there's very strong reduction, while in some of the other regions, like in ECA countries, the baseline does not offer very significant drop. However, potential is really there to remove emissions. To conclude this in terms of what it means in terms of exposure or concentrations and exposure, you see here a map for PM2.5 concentration starting from 2015. In terms of colors, the white area is indicating area where the model is estimating concentrations below the current WHO guideline of 5 micrograms. And the areas that are red are largely above. Orange and red, this is above the current EU standard of 25. That includes also natural sources. So you see here a lot of dust sources in the south, I mean, in Southern Africa, actually here. But there's also regions currently like Po Valley in Italy, where it's all red. There's a lot of yellow areas that are also exceeding the 20 micrograms currently, but they are improving significantly in the baseline and largely disappear, but still far from compliance with the WHO recommendation. And even in 2050, there are a number of areas, in spite of the climate policy and the European Green Deal included in this policy, where the concentrations are above 5 or even above 10 micrograms. There are opportunities and technical measures that would offer further mitigation. In terms of exposure, you will see here that in 2015, a rather small proportion of population was exposed to levels below 5 micrograms, and a still significant population exposed to levels above 25. And on the right side, you see that this white bar is increasing significantly. And there's also, comparing to the Gothenburg Protocol commitments, the current pathway is not quite achieving that everywhere. So there is a potential to increase, there are still further benefits of pushing stronger and achieving actually compliance with the Gothenburg Protocol. Just a snapshot on acidification. That's been largely a success story in terms of a baseline. The exceedance, the percent of ecosystems above above the critical loads for acidification has been strongly declining over time. I'm not showing here 2005 situation, but 2015 towards the future shows for EU and non-EU countries that a very small proportion, only around 2% and below of ecosystems, will be still exposed to levels or will have the position above critical loads, while the picture for eutrophication that was already mentioned in previous session is actually does not look good at all, and there is a very little decline. There are opportunities to reduce that, and that will be certainly a subject of further work to develop successful strategies to successfully reduce that. Coming to conclude this, I think what we have learned so far from the application of use of science in this policy discussion, there is a place for science. It takes time to build trust in science and build the results and the models as part of the whole discussion. What we learned also is that the robustness of results is often more important than uncertainties and presentation of uncertainties, because they also are very difficult to be used. They shall not be forgotten, and science is, of course, presenting them from the policy perspective. We have to focus on robustness that's proven to be an successful approach. I would like to highlight the last point also, that involving stakeholders from industry, NGOs, and many countries, of course, is absolutely essential and has proven to be very important. The tools like GAINS model or integrated assessment models can reveal a lot of win-win solutions, but we have to remember that the tools and the application have to be based on robust science and appropriate methods, supported by peer review process. They have to be illustrating consequences of alternative policy decisions and embed everybody in discussion, be transparent. And this is one of the processes, one of the elements that is very important, again, is this participatory process in the whole discussion. I want to finish with a chart that is a different way of presenting, actually, in a way, a structure of convention, but a very limited element of that, only from the perspective of the EM models. As I mentioned earlier, and has been mentioned in previous presentations, the information about the mission, technology, atmospheric modeling, health and ecosystem impacts is considered in this integrated assessment modeling. And it's jointly developed and discussed between both scientific community as well as member states and the stakeholders, including industry and NGOs. Within the convention, we have centers that deal with these aspects, as been shown already in previous presentation, and expert groups that are discussing and advancing knowledge and make sure that the latest available knowledge is actually used in modeling approaches and used in the discussion. And that's part of the peer review process. That's part of the building database about best information on this, both sources, ways of mitigating them, as well as impacts. And this is supporting the development of the policy option scenarios that are provided within the convention through the task force of integrated assessment modeling and further on to the policy negotiations, both at the level of the Commission, Air Convention, as well as European Commission. This is the same process. And I would stop here. Thank you very much.